Okay, there's a theory that women tend to marry older men. So a sociologist decides to analyze this, kind of piece of common knowledge to see if it's actually true. The sociologist samples 100 married couples to find out the age disparity between the husband and wife of each of these married couples. And the age of each husband and wife is recorded on a spreadsheet. I'll go ahead and show you that spreadsheet. So here we go. We have 100 couples in column A, and we have the husband age and the wife age. So the first thing we want to do is figure out what type of test is this. So this is a test of difference of means. I want to know, is there actually difference between a husband and a wife's age? And I'm going to add something to this. I'm going to say this is a test of difference of means, match pairs. So what does this match pairs mean? This means if we go back to the spreadsheet, we've got the husband's age and the wife's age. So it looks like there's two data sets of 100, but we're going to think of this as just one data set of 100 because we really just care about the difference. This pair is coupled up, this pair, this married couple is coupled up, and so on. So I'm not going to take the mean of the husband and the mean of the wife separately. What I do right here is take the difference of, let's do the husband's age minus the wife's age. And we're going to go down the line like this, and this will be our differences. Minus means the wife's older, 18 years older, 2 years older, and so on. So we do have a difference of means, but they're matched up. So we're going to let mu sub h be the true population mean age of the husband. And let's say mu sub w, the true population mean age of the wife. And I'm going to add something else. I'm going to let mu sub d be the difference. And I'm going to take the husband's minus the age of the wife. So d will be the population difference, husband and wife. So if we're thinking about this, this is our sample data. So sample husband age, sample wife's age, sample for the difference. Okay, now that we have our variables, let's write out our null hypothesis. It's always we're using h naught for that. And we need to have an equality. So there's a couple ways we can write this out. We need to assume in our null hypothesis an equality about our population parameter. In this case, it'll be our population mean age of the husband and wife, or the difference. So I could do a couple things. I'm going to assume there is no difference. So our difference in husband and wife is 0. Another way to write that would be to say that the mean age of the husband equals the mean age of the wife. So we're assuming there is no difference between the age of the husband and the wife. So for the null hypothesis, we assume the mean age of the wife is the same as the mean age of the husband. So we're assuming on average, husbands and wives are the same age. And what about alternative hypothesis? We're testing a theory that women tend to marry older men. And that's the reason why for the difference I put mu h minus mu sub w, because that works pretty well with our alternative hypothesis. I'm going to assume my difference in this case is greater than 0. So our alternative hypothesis is that this is bigger than 0. And if we write this out, this is that the mean age of the husband minus the mean age of the wife is greater than 0. So writing out, just another way of writing out our alternative hypothesis is that the mean age of the husband is greater than the mean age of the wife. Subtract the mean age of the wife from both sides, and we get that this is greater than 0. So the alternative hypothesis is that the women do marry older men. And there we have hypothesis written in two different ways notationally in English, and our alternative hypothesis written in two different ways in mathematical notation and in direct English.